Okay, we're going to just do a basic introduction to the kidney. We've got 3 slides here of progressively more magnified views, so we're going to get these real close-up ones out of the way for a second. We'll start with just the general kidney tissue here. And so overall, we don't have a very high resolution, but that's okay. That's not really what we're looking at here. What we're really looking at instead is actually just the difference between the cortex and the medulla of the kidney. And if you can see, right around here, the tissue really transitions. Up here, you're going to see these little circular structures right here, and here, and here. Here is a couple there, and there, and there. And so you can see those all right now, and I'm going to remove the drawing just so that you can see them without the aid. So again, take a look around and make sure you can pick out those glomeruli. So the singular term for that is a glomerulus. They are the functional units of the kidney, and they're only going to be found in the cortex of the kidney. So where you see glomeruli, that you know you're in the cortex. Where you see them kind of start to not exist anymore, and you start to only see tubules, to me, I think it's right around there. And so you're making, your best guess. And I think that that's a pretty good point. Anything below here is in the medulla. Everything above here is the cortex. And so if you look at that, you can see the big difference is the glomeruli. But as you get into the cortex, you see these much larger tubules, which are going to lead to structures which you can't see in total here. But these big openings, these cracks that you see here, that's getting down towards what's called the renal papilla. And that's where filtrate is actually going to filter into the minor calyces of the kidney. So let's get this guy out of the way. Really just looking at introducing the glomerulus with this one here and the difference between the medulla and the cortex. As we get a little bit closer, we get a better perspective of the actual glomeruli here. You can see a large blood vessel, probably a segmental artery here. And what you can see is the majority, we're in the cortex, we know that because the glomeruli are all over the place, you can see them all over. But all of this whole bunch of tubules here, really the cortex is made up of either proximal or distal convoluted tubules. About 85 to 90% of the tubules, maybe even more in the cortex, are proximal convoluted tubules. And so everything inside of that circle that I just drew, almost every single one of those are proximal convoluted tubules. These are big tubules, they kind of have a blurry border, meaning it's not a nice clean edge within its lumen. And you can see them here. Get these all out of the way. And you can see we're on one glomerulus right in the center here. And you've got a nice proximal convoluted tubule. Let me switch colors there. Proximal convoluted tubule there. There as well. This guy here. So these are big tubules that always look like they have some kind of particulate in the middle. It's not this nice clean opening. And you can kind of contrast that with this tubule here, which actually has a cleaner opening and is sitting right up next to the glomerulus. And that's likely a distal convoluted tubule. It's kind of a large one. Usually the DCTs are a little bit more circular. This could be one right here. And in the distal convoluted tubules, what you'll notice is that in any one circle, one tubule, you will actually probably see all of their nuclei, all of the nuclei of the cells that border it. So in here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm counting 10 nuclei within this tubule. Whereas if you go and try and do that same thing, just count up the nuclei in a proximal convoluted tubule. Let's take these two right here, this one here, this one here. As you notice, there's one nucleus there, maybe 1, 2 more there, so 3 total, and here you're seeing about 3 total. So the point is that a proximal convoluted tubule, the cells are actually so big that usually in one tubule you're not actually going to see nearly as many nuclei. They're not going to be nice and organized like you see in other tissue. Whereas in a distal convoluted tubule, the cells are actually smaller. So when you cut it, you're probably going to cut through that nucleus in every single cell that you see. And so that's kind of one way to interpret and to guess basically what the size of a cell is that if you see all the nuclei, that means every single time you cut through those cells of the distal convoluted tubule, you actually hit the nucleus. And that's because the cell itself is smaller and the chances of you cutting through the nucleus are greater. Whereas if it's a big giant cell, meaning it has a lot more cytoplasm, the chances of you cutting directly through the nucleus go down as the amount of cytoplasm goes up. And so you'll tend to get cuts that look like this, where you actually have cells where, man, it looks like there are only 3 nuclei within the proximal convoluted tubule. It appears that way, but in fact what you've done is you've actually just happened to have not cut through the nucleus in this area here and this area here. Those are cells. There are probably 9 cells that make up the border of this tubule, but they're just so big that when you cut through them, you don't happen to hit the nucleus every time. And so again, that's one way to be able to judge the size of an individual cell in 3 dimensions. And so proximal convoluted cells are much larger. There's a lot more going on in the proximal convoluted tubules, whereas the distal convoluted tubules are simple. They're much smaller tubules. So you're generally going to see all their nuclei in a nice circle. So that's about it for now. The video's long enough. We'll do another one specifically looking at the macula densa, the renal corpuscle, and all those individual components. I'll talk to you later.